All right. Somebody tell me if I exist. How will I know? I think I should be live now. If I'm not, someone will have to tell me. So no special guest this week, just me. And this isn't because I didn't want to set up a guest, but because people have been giving me a hard time that they want the live shows as well. So I figure let's take a second. We'll just do just me, and then you'll be like, oh no, actually, we do want a guest, Fraser. This is terrible. This is the worst. So this, and we'll get through all of your questions, and then we'll be done. And then we won't need to for another 10 years or so. But hey, everybody, thank you so much for joining me today. A bunch of questions already came up already, so I thought I would get into them. Pray for Mojo asks, is our sun capable of a super flare? Yeah, our sun is capable of very bad flares. The sort of most classic bad flare that we've seen is this thing called the Carrington event that was seen like back in the 1800s, and an astronomer was looking at the sun, saw this really bright flash, made a note of it, and then several hours, 2 days later, very powerful flares, very powerful solar storm passed the Earth, caused auroras that could be seen from like the middle latitudes. Power was pushed down telegraph lines, and telegraph poles caught on fire. So it was bad in that a bunch of telegraph lines caught on fire, but that was 200 years ago. Now, or 150 years ago, so now, with our completely interconnected society, a flare of that magnitude would be a very bad day. And imagine if all the electrical grids around the world broke down simultaneously and a bunch of satellites went offline. So it would be really scary and suck. But that's not the most powerful. We've actually seen even more powerful flares coming off the sun. They just weren't headed in our direction. So we've actually seen sort of, a really bad flare, but just went in a different direction. And astronomers think that we get about one every 500 years or so. And so who knows if we'll get one. The solution is to break up our power grid so that you can have an individual component have a charge go through it, but it won't take down the whole power grid. And we're kind of moving that direction as more people get solar panels on their roof, people's cars act like big batteries. I think we're going to get to this point where we will have a broken up enough grid that we won't get a devastating super flare. But it could happen. But it is nowhere near as bad as the kinds of flares that we see on red dwarf stars. So these are, of course, the really small red dwarf stars. They can have flares 10 times, 100 times, 1,000 times as powerful as anything that we have from the sun. And of course, if planets want to orbit a red dwarf star, they have to be really close. And so you would have this situation where the star blasted off a flare that was many times more powerful than anything in the sun, and the planets are hugged up close. So they literally just get the life scoured right off of them. So we should be glad that our sun can't produce that level of dangerous flares. Thanks for the donation, James Smith. I really appreciate it. All right. So Face Gallon asks, how much does a decent light telescope ask? And Astro Creations asks kind of the same question. So the telescope that I recommend is not this one. I recommend that everybody gets an 8-inch Dobsonian telescope. So Dobsonian, they are light buckets. And they are really easy to get to use. 8 inches is small enough that you can pick it up and carry it out into the front yard and enjoy being able to quickly slew it around and show people the night sky. And so when you're like, oh, there's Mars, there's Saturn, there's Jupiter, there's Pleiades, there's the moon, the 8-inch Dobsonian is just the right machine to do that. And they're not that expensive. You can get one for $200 to $400. Don't go bigger than that. And don't go with any kind of automated mount. And if you find yourself using the telescope, you're out all the time, you're really enjoying your Dobsonian telescope, then come back and we will talk. But until then, yeah, Dobsonian is absolutely the way to go. All right. Paul Kopp asks, when will we stop speculating about terraforming Mars without a magnetic field to protect the atmosphere? It seems pointless to speculate about terraforming Mars. Thoughts? All right. So terraforming Mars, I think, says more about human beings than it really says about the habitability of Mars. Whenever we see a problem, we want to fix it. Mars sucks. How can we fix it? Well, okay, fix the atmosphere, you can put a big shade in between the sun and Mars at the L1 Lagrange point, and then that will stop the solar radiation from removing the atmosphere. The atmosphere will thicken a bit, and it'll warm up to the point that the ice caps will melt, and that will thicken the atmosphere some more. And then people are just still going to have to live underground because the galactic cosmic radiation can't be blocked. There's really nothing that you can do to fully stop that radiation. And so people are going to be stuck living underground on Mars pretty much forever, right? So because, I don't know, we're human beings and we see a problem and we want to try and fix it, at least in our minds. So, I think that's what it is. And yet we are forgetting that we live on the most beautiful, well-terraformed planet that's ever existed, that we know of in the entire universe. The best place in the entire universe that is good for humanity, and we happen to live here. So you can go wherever you want, go to Mars, but you'll want to come home because it's awesome. All right. Flip-Flops asks, since the universe is only 13 to 14 billion years old, what's the chance of future intelligent life if the universe is expected to last for 10 to the power of 92 years? Well, we don't know. I mean, yeah, the universe has been around for a very, very, very long time, right? It's been around for 14 billion, 13.8 billion years. We know that life has formed on Earth within the first billion years, that the sun, that there are stars out there as with the same kind of metals as our sun that have been around for many billion years before we got here. And so it seems really weird that the only evidence of life that we can see in the entire universe is right here on Earth. And that is, of course, the Fermi paradox, right? Light should be everywhere, and yet we don't see it. And so who knows? Imagine if you got a million universes, and only in one universe life could actually form in the entire history. Well, that life would go like, where is everybody, right? Even though 1,000 universes formed before it, and life never arose. So we still don't know. Are we the only life in the entire universe? Are we the only life that will ever exist in the future of the entire universe? We don't know. It's just until we can find another example of life out there, we can only speculate. The Fermi paradox is the most troubling thought that I think, it keeps me awake at night. And I think if you're not haunted by the Fermi paradox, I don't think you've thought about it enough. So that's my take on it. Sisypho Price asks, will that 8-inch Dobsonian be good at all in city conditions? Yeah, well, I mean, the city conditions are where that Dobsonian really shines, right? It's the bright stuff. It's the planets. It's Saturn, it's Jupiter, and all that stuff looks great, even from a city. You can be in the worst light pollution and still see Jupiter almost as well as a person who lives in really dark skies. It's the really faint stuff that you're not going to be able to see very well, but with the faint stuff, you're going to want a really good tracking telescope anyway, so don't worry about it. Arpuva Singh, what's up with the space race in the USA? What are we trying to achieve? Well, I'm Canadian, so I don't know. We think that everything needs an arm on it. That's what we're trying to achieve. More places with more robotic arms. That really is the new space race. So if you want to build an arm on all the things in the universe, then come at us. All right, I'll give you a more feasible answer here. I think that there's sort of two parts to it, right? One is that landing on the moon back in the 1960s and 70s was really just a tremendous accomplishment. One of the most amazing accomplishments that human beings have ever done. We left planet Earth and we landed on the moon, and the United States was the country that did it. And so to not be able to land on the moon right now, I think, is crazy making for the United States, because like this is a thing that we used to be able to do and now we don't do it anymore. And the reason we don't do it is because it's incredibly expensive. It's like building a really big cathedral, and then you're saying like, we built this really big cathedral. How come we don't build them all over the place? Well, because building that one cathedral took 100 years and all of the, raw resources of your entire country to make that happen. So you don't get a bunch of them, you just get one, and you're really proud of it. So I think that is why there's this kind of imperative from the Americans. Is just there's this feeling that we did it once, we should be able to do it all the time, anytime we want, just come and go. And I think we should. And by we, I mean, the Americans, and then we will attach an arm to it. But, and then you can see groups like the Chinese on their way to landing on the moon, and that stirs that need to prove that you've still got it. And I think that's what it's about. So, and I think having the capability to go to the moon is really important and really exciting. And yet I don't think it necessarily needs to be a space race. I'd like to see a collaboration, something where it could be SpaceX with, I don't know, the Indian Aerospace Agency with their whatever. Like, let's just see some people figure some stuff out. And I personally think a far more useful space race would be building some kind of rotating artificial gravity system out there in orbit. I'd like to see that first. All right. So thanks to the mods for posting all the questions that I'm seeing. I'm able to check them out as we go. Let's see. Randy Brizendine asks, how powerful of a magnetic field would stop the radiation that is found outside the Van Allen belts? What options are available for SpaceX to travel to the moon and Mars? This is a problem, an artificial magnetic field, and I've done a whole video about this. This is an artificial magnetic field to block the radiation, just like the Earth does with the galactic cosmic radiation and the solar radiation. The radiation from the sun is not that hard to block, but the galactic cosmic radiation is really tough. It is, we don't have any kind of technology that can stop that stuff. And that stuff just will give you cancer over long periods of time. It's just steady cancer rays. So the only solution is to go quickly. So you spend as little time as possible in space. Surround yourself with as much stuff as you can, your water, your food, any of your building supplies, hide inside of it, and go quickly and accept an increased risk of cancer. That is the best we've got right now. And I know it would be great to have something better, but nobody has anything better. But I've done a whole video on this. So I'm sure somebody can post the link to it about the how do we stop radiation in space. Brad McGashett, hey Fraser, would you personally go to Mars if you had the chance, and how would it work with kids? Do I get to come home? If I could go to Mars, the classic answer that I think it's the one Neil Tyson used, was I'll go after Elon Musk's grandmother returns safely from Mars. I will do that when it's safe and I can return safely and I can go for, but man, like a 6 month, and the trip takes like a month at the most, then I'll go. Andy Lee Robinson, I'd like to see an interferometer built about the size of Mars's solar orbit. Would give 40,000 times increase in resolution. Any plans for such a size? There are no plans for such a size. So that would be great. A space-based interferometer would be wonderful. This is when we think about the Event Horizon Telescope, right? This was the telescope that was the size of planet Earth that was able to take a picture of the event horizon of a black hole. And it did that by all of these telescopes on various parts of the planet acting like one telescope with the size of the planet. So not the collective light power of all the different radio dishes, but actually it acts like a telescope as the size of the Earth, sort of. But I really need to do my interferometer episode. I will, I promise. But based on that, it's easier to do, in that they had to fly, airplanes filled with hard drives around, to do with radio waves at the 1.2 millimeter wavelength. Literally impossible to do with visible light. So the only way you can do it with visible light is if you do it in real time, where the telescopes are close enough together that you can interfere their light together and figure out when you're off when they're not perfectly aligned. And so there were some ideas. There's this idea called the Terrestrial Planet Finder, which got canceled about 10 years ago, and there's been no plans to build a space-based interferometer for now. But based on the success of the Event Horizon telescope, I can imagine people considering building new telescopes that will do that. All right. Yeah, so Pup 314, you're saying the same thing, right? Like, build telescopes wherever you want, separate them with as much as you want. The only challenge is that you've got to be able to align the wavelengths to the actual specific wavefront. And the only way to do that is to use a really big wavelength like radio or microwave, something like that. As they get really small, it is just impossible after the fact to be able to line them up perfectly. So, Bob, what's the point in bigger telescopes if we can't see past 13.8 billion light years? Well, the crazy part, right, is that we can't see beyond right now more than about 5 billion light years away. So the Hubble Space Telescope can really only see out to about half the way out to the edge of the observable universe. And it can see farther than that by using either like going for a long time, but also using what's called gravitational lensing. So they'll use the gravity of various galaxy clusters to be able to show, it acts like a natural telescope to see what's farther. And so that is like, with the next generation telescopes, say James Webb is going to give you resolution right, almost to the edge of the universe at resolution. And that's the key, is like resolution. Jupiter's way closer to us than Andromeda, and we could see clouds on Jupiter, but we can't see clouds on the stars and planets in Andromeda. With a bigger telescope, maybe we could see clouds on the planets around the stars in Andromeda, but we couldn't see them in M87. So bigger telescopes are always better. Bigger, better. Vilhelmo de Occidento. Does the rate of expansion differ within solar systems versus the space between solar systems versus the space between galaxies, etc.? Right. I get this question all the time, which is like, if the universe is expanding, why isn't the solar system expanding? Why isn't the Milky Way expanding? And the reason is because the gravity that holds together the Earth, and the gravity that holds together the solar system, and the gravity that holds together the Milky Way is the dominant force in the region. So yes, there is this expansive force that's going on that is attempting to spread apart the Milky Way from both the leftover expansion of the universe as well as this acceleration from dark energy, but the gravity of the Milky Way holds itself together, and so it doesn't grow. But on much bigger scales, where you are looking at hundreds of millions of light years apart from each other, say two galaxies, they are pulling each other with their gravity, but the expansive force is too strong, and so they move away from each other. And so at a local level, we just beat the force of gravity. And you can think of it like the force of gravity is pulling you down into the Earth right now, but yet you don't sort of get absorbed into the Earth. And that's because the atomic force that holds your atoms together is too strong for gravity to be able to tear you apart and absorb you into the planet. So there you go. John Victor is asking, when does NASA meet for the Decadal Survey? I think the next Decadal Survey comes in just a couple of years, 2022. I'm sorry, I'm doing that off the top of my head, but we're due. Like, they're getting ready for the next Decadal Survey. So we've done a couple of videos about the Decadal Survey and when it actually does come together. And this is this idea that various astronomers and scientists get together every 10 years and define their priorities for what big scientific questions they're trying to study. And then they pass this all along, and then NASA and the National Science Foundation develop various space telescopes and satellites and science experiments to help answer some of these questions. And everything that you are that you're familiar with, right? All of the spacecraft, the James Webb, Kepler, all of these are the result of previous decadal surveys. And so it's a very exciting time. I really enjoy the decadal survey because it really just defines the sort of like what are the big priorities, and then we get to watch this unfold over the next decade as they get built. Let's see. Tom Downs, when planning to do any live telescope Q&A anytime soon? Yes, I am. Thank you for reminding me. Guilt is the best way to motivate me. So yes, I really want to. Let's see. Neptune the Mystic. Do you think we need an international space agency to have bigger budgets for advanced missions? I don't know whether... I mean, the International Space Station was a great example of an international collaboration between countries. And I think that it was a triumph of engineering and construction. In fact, I dedicate some of my next episode to this, coming out tomorrow, all about space construction. And at the same time, obviously, it cost an enormous amount of money. And that was an international space agency. When you really think about it, all of these groups, Russia, the United States, all these other countries working together, built this thing, cost a lot of money. I don't know, sometimes big groups are required to make big investments and make things happen. Other times, small, nimble organizations are able to make more headway into a challenging problem. They don't have the existing momentum and inertia. So it's hard to say. I think you need both. You need deep-pocketed organizations that are able to make big projects happen, and you need to have the opportunity for small, nimble groups to help us reimagine what's possible. And it's those two working hand in hand. So I wouldn't want to go with one big agency. I could just imagine the bureaucracy. That would be rough. And yet at the same time, I can imagine small companies. Some of my favorite little aerospace companies keep having financial problems because they can't afford to continue doing research in the way that a NASA group can. And that sucks, right? So there's got to be some better balance, and I don't know what it is. All right. Curious Borg asks, is there a theoretical upper size limit for black holes? No. Just as much stuff as they could eat. You could put all the observable universe into one black hole if you wanted, and it would be very big, very massive, and would take a very long time to evaporate. Sam Borston, what could we accomplish by around the year 2130? That's a very specific date. Do you have a plan? Do you have a deadline? I don't know. Who knows what the future holds? I think it's really hard to see the future beyond a certain point. I mean, when you look at how far our phones have come in 10 years, I can't even imagine what another 10 years of phone is going to look like, or another 100 years of phones are going to look like. So in terms of space exploration, I think that my hope is that we will have cracked space-based construction and space-based harvesting of resources. And if you get those two things happening, then you've got robotic factories self-replicating themselves across the entire solar system, and you can kind of accomplish almost anything. So I think it'll be shocking how far along we are 111 years from now. Paul Kopp wants me to speculate about the possibility of life on Titan. Well, the cool thing about Titan is it's a twofer, right? So you've got the top layer, which is this weird, cold methane environment where it rains liquid methane. It collects into, or ammonia, all these hydrocarbons, they collect into oceans and seas. And then you've got rivers and deserts and sand that blows around, but the sand is actually water ice. So you've got what, when you've got a liquid environment like that, you've got the potential for life. Now, it's not life as we know it, but it is potentially life. But we don't really have the right tools to be able to find it, but maybe we will. Who knows? And obviously, if we saw one scampering across the surface of Titan, that would be crazy. But then you've got the sort of this shell of ice, and then it looks like Titan probably has a water liquid ocean underneath a shell of ice, like Europa or Enceladus, but it's big, right? Titan is the second largest moon in the entire solar system. So you can imagine that all of the same possibilities that are at Enceladus could be happening on Titan as well, that you've got this liquid ocean where you've got volcanic vents down below that are providing energy, and life as we do know it could be existing down there. So I think it's kind of mind-bending how much possibility there is for life on Titan. And that's why we need to go back to Titan, and we need to explore it as much as possible. I think if I had to pick one place to go back to, it would be Titan. Titan, please. Bob, are any of the planets or moons in the solar system captured from another star system? Probably not. There are a couple of asteroids that are orbiting, I think, or one asteroid that's orbiting Jupiter in the wrong direction. So it should be orbiting backwards from the rest of the moons of Jupiter, but it's orbiting in the right direction with most of the moons of Jupiter, which is unexpected. And one of the thoughts is that it was a captured interstellar object, because for it to get into that kind of an orbit would be pretty weird. But that's about it. There you go, Pup 313. Yeah, it's in a prograde orbit. So I think if we could get out there and we could sample every single significant object in the entire solar system, then we would get a sense of what is out there. And maybe one of them would have an age that didn't match the rest. And there are millions of objects that we could explore. So it's something that we should really do. Janelle Duncan, do you think it's possible to retire on Mars in another planet in 20 to 30 years? 20, yes, I would say in 30 years there will be an option that you'll be able to retire on Mars if you want to. In that, I think that SpaceX, if you recall, SpaceX was planning to send humans to Mars by 2024 on the Starship. I don't think they're going to make that goal, but add 30 years on top of that. That doesn't sound crazy. So, but will you want to, right? Like, do you want to? Is that what you want to do? Is retire on Mars and never see another ocean and never see another tree and never see another forest and never see frogs and deer in the wilderness and all that kind of stuff, right? You're going to see dirt and rock, and most of the time you're going to be underground struggling for survival. That is retirement on Mars. So I think it would be great to visit, but I wouldn't want to live there forever. But that's me. And I know there's some people, and they're not crazy, and they want to live there. So Cody from Cody's lab. He'll do it. He wants to do it. I don't know why. Randy Brizendine asks, how would a company capture an asteroid from mining to begin space-based manufacturing? Could it be brought back to at least lunar orbit? Sure, there's lots of ways, theoretically, to move an asteroid. So I can imagine someone wanting to take an asteroid that is already in a fairly useful orbit and then maybe move it to one of the Lagrange points, say the L2 or L1 Lagrange point, where it would be a really nice, stable-ish asteroid, or maybe go to the L4 and the L5 Lagrange points, which are stable, and then you could then just extract resources and bring them back to home, or build stuff in space and go from there. So I think that will be a very useful step. Once we have gotten a lot better at extracting resources from asteroids, we're going to want to be able to move them back. Yeah, Larry Beckham says, I prefer Costa Rica for retirement. I agree. Costa Rica is amazing. I'll totally retire there. With a visit to Mars. Like, I want to visit Antarctica. If I could go to Antarctica, I would totally do that. I would love to see Antarctica. Yes, please. Let's see. Sam Borston asks, do you really think that with alien life, we really need to think outside the box? People always make this comment at me, which is like, we're so arrogant that we think that life in the universe is going to look like life as we know it. Why do we look for life as we know it, right? Well, let's get creative. Well, we haven't even tried to find life as we know it yet. That's the challenge, is like let's give looking for life as we know it a better crack first. And I always use this analogy of, like, if I said to you, could you give me an apple, please? And then you'd be like, well, okay, I'll go check the apple tree, and I'll go check a grocery store, and I'll check to see if there's one in the fridge. And if none of that worked, then you might start getting creative about the places that you look for apples. And you look under the bed, and then you'll try looking in the trunk of the car, and then you'll try looking, at the bottom of the ocean, and you'll get more and more extreme. So I think that right now we know that everywhere on Earth that there is a drop of water, there's life. And so it seems like a really good idea to go to all the places that we have found water in the solar system, liquid water in the solar system, and say, is there life there? And we haven't even done that yet, right? We haven't even, right? And back to my Apple analogy, like someone pointing out to you, there's a place called the Apple Store. Turns out they only sell computers, but you would look in there, right? So I think that we haven't even checked the ice geysers coming out of Enceladus in Europa. We haven't seen, we haven't looked in the salty brine under the surface of Mars. There's all these places that we can look where there's water, and maybe we'll find life there. So let's start there. And then after that, by all means, let's get weird. And Sam Borston says, how much credit would I give Elon Musk for space exploration? Also, he believes in wacky life as video game theories that have no basis in science. He believes in the simulation theory, which is a compelling argument, right? The simulation hypothesis is a pretty clever idea. And when you really think about it, it's really hard to argue against the simulation hypothesis, but also it's pointless to live your life any other way than that the life is real. So don't bother. How much credit would I give Elon Musk for space exploration? A ton. He and SpaceX utterly changed our philosophy about what is possible with a rocket. That before SpaceX, the expected truth was that you couldn't land a rocket. And yet here we are seeing rockets land, and now we're just waiting for the fully reusable Starship, which will be like as reusable as an airplane in theory. That is a step forward that nobody has ever been able to demonstrate. And yet, by going back to first principles, Elon Musk and team have demonstrated that this is possible. And it's incredibly exciting. I mean, it's going to lower the cost of access to space by orders of magnitude. So it's hard not to feel like that has unlocked space in the craziest way. In fact, we're working on some stories about Starlink, which is the internet system that SpaceX is planning to do. And their plan, right, is to launch 12,000 satellites, which is about 10 times more than our active satellites in space right now. But at a very low altitude, just like 400 kilometers up. So they'll all re-enter the Earth's atmosphere every couple of years. So it won't cause a lot of space junk, which is good. But it'll also allow very quick communication, like ping times that you could play games on at gigabit speeds from anywhere on Earth. You want to have a cabin in the middle of the forest that has high-speed internet? Go ahead. So that's just one idea. Like, can you imagine what happens when they're operational and everyone just gets to finally tell their mobile phone provider to get lost? I can't wait. Make it happen, Elon Musk, please. All right. Rich Wilson, I thought we've been working on landing rockets in the 70s or earlier. Also, wasn't the X Prize where the new space race was born? Yeah, I think, if you trace back, I mean, Peter Diamandis and what happened with the X Prize was a really big inspiration. A lot of us, actually, space nerds, can trace our excitement back to, I would say, Robert Zubrin is the one who, if you read books about Elon Musk and his excitement for rocketry, he was inspired by Robert Zubrin's case for Mars. And so was Jeff Bezos. And I think there's a lot of inspiration there, with a lot of other people. I started Universe Today because I was excited about what Robert Zubrin had proposed with the case for Mars. It's only after 20 years of doing this if I started to get excited about Earth and not Mars. But I think that you can sort of trace these ideas back, and I'm pretty excited to see what happens next. Brad Magashit, would it be feasible to place some kind of reflective dust cloud at Earth's L1 point to dilute the energy of the sun and stop global warming? Sure. Yeah. I mean, there's lots of ideas that you could use to try to minimize the amount of radiation that's coming from the sun. The L1 point, you could put a great big disk out there that blocks some of the infrared radiation but doesn't stop the visible light. But these are like mega engineering challenges at a scale that we can scarcely comprehend. I mean, the most doable one that I've seen is this idea of spraying particles into the atmosphere at really high altitudes with essentially rocket planes. And it's, might cost a few $billions a year to maintain, and would give us a little bit more time to battle global warming. But we don't know what the unforeseen consequences are of manipulating the entire climate of planet Earth. It's scary. And so I think we should start with severe carbon emission declines if we can. Let's plant a lot of trees and cut down our requirements on carbon. That'd be great. I'm always nervous and think about the unintended consequences of gigantic geoengineering projects. I mean, we've seen what happens with plants. Someone goes like, "Oh, this would be a good idea. This would be a nice plant to put in my garden," and then it tears apart a chunk of the natural environment. We've got this awful plant here on Vancouver Island called broom, and it's just everywhere. Just because someone wanted a little piece of Scotland, and they just planted it in their backyard, and it took over the whole island. And we're constantly cutting it down because it's killing off our regular plants. So, I mean, just the unintended consequences of the smallest actions is a thing that we need to think through. Gorilla, do I think that life ever existed on Mars? I've heard the view that it would have been detected by now if life had been there once. We don't know. It's worth looking, right? And this is why NASA is sending spacecraft to Mars to search for any kind of evidence that there's life there or has ever been there. And the Spirit and Opportunity and Curiosity have been following the story of water on the surface of Mars. Has there been water there for long periods of time? We look at what happens with the Mars 2020 rover. It's going to be looking to see if the conditions for life were good in the past, and we're working our way towards some kind of conclusive evidence that yes, there was life on Mars at some point in the past. There's obviously nothing big, right? We don't see petrified trees on the landscape. We don't see fossils, but it has been billions and billions of years the since Mars dried up, so all that evidence could be lost. So it's going to be hard to find, but we don't know. That's why we're looking. Henrik Leschner. Do you have any viewers outside the U.S. or Canada? It's hard to find excellent material like yours to learn about space-related news on non-English languages. I don't know. I could tell you. I mean, I could look at my usage stats. About 70% of my viewers are from the United States, maybe 5% from Canada, 10% from the UK, Australia, New Zealand, India. So, yeah, I don't know what the solution is. My French is terrible, even though I'm Canadian. So, it's great. And I think I have like 99.3% males watching, which is kind of sad. I wish there was sort of more parity, more in that, but here we are. Oh, Crush Nut, what's the biggest error you've made while reporting on space and science? That's a great question, and there isn't a big one, but I make them all the time, right? We little ones, like just verbal typos. Like I think I said in an episode about sending nuclear waste into the sun. I said that the Earth moves at 30 meters per second, when of course everybody knows it moves at 30 kilometers per second. That's a factor of 1,000. I should shut my channel down. So yeah, I make verbal typos all the time, and people usually catch them. Sometimes I think I'm right though, and people think I'm wrong, and that's fine. We get to have an argument about it. Others have been bigger. And sometimes I have had in the past, less so more recently, but fairly fundamental misunderstandings about the way things worked. And I hope that's one of the benefits I get from doing all this work just in public, right? In real time, is I'm forced again and again and again to answer the same questions, to learn my mistakes and be able to sharpen what I know and make sure that I don't make the same mistakes twice. And I try to do that, and I hope that I'm able to be both entertaining as I say things, but also be precise and correct as I say things. And that is just a process of learning and saying a bunch of times. So I have said many things, and of course my pronunciation, but I get to just chalk that up to my hilarious Canadian accent. Z-Trex, how many years do you think before we start asteroid mining? I think that it's funny, like there's a couple of companies, and we actually, if you watched last week, we talked quite a bit about asteroid mining, and there's a bunch of companies, Planetary Resources and Deep Space Industries, that have developed some really fascinating hardware for mining. And I think asteroid mining is going to be the technology that really unlocks that solar system spanning civilization. And yet, both of those companies had a really hard time. Planetary Resources had to be sold to a Bitcoin company or something in Liechtenstein. And I don't know where Deep Space Industries are at, but those are really fundamental, interesting technologies, and they're having a hard time paying for it because space is hard. So I think, though, it's maybe they're too early, and then when the technology from SpaceX becomes better, then we will get more sort of more sustainable mining, and then we'll go from there. Bob asks when we get a bloopers episode. We release the bloopers all the time to the patrons. There's 4 actually I have to review and upload them, so I apologize, and I will upload them shortly. Patrons. Paul Kopp is asking about the arcade mission. I have no idea what you're talking about. I'm sorry. I'm not familiar with that, so I'll have to look into that. Gwym, what is the most exciting project starting to come together in the near future? Man, where to start, right? I think the Europa Clipper mission, which we're going to do another episode on the Europa Clipper shortly, so it's sort of in the works, is amazing, right? This sending a spacecraft back to look at and potentially maybe land on Europa and fly through the cryovolcanoes that are coming out of Europa. That would be incredible. That, yes, please, that one. And then, of course, from a telescope standpoint, LUVOIR, right, the large ultraviolet optical infrared telescope, a 15 to 18 meter space telescope. So a telescope that's bigger than anything that's ever been made on Earth, but in space. Yes, please. So there's a ton. And I think Starlink, as having high-speed internet anywhere on Earth, is really exciting. So in fact, I think my whole channel really is about me being excited about stuff that's just about to happen. So I think every single video that I make, tomorrow's video is all about construction in space, about building 3D printed structures, 3D printed space telescopes and such. So everything I talk about is all stuff that I'm excited that's mostly happening soon or are there to solve problems. That's sort of where I'm a little different from, I think, some of the other people, is I like to think about the near future, not the far future. Far future, I'm not that excited about the far future because it doesn't feel realistic to me. And so I just know that there's no point trying to predict what's going to happen 100 years from now, 200 years from now. We'll all be uploaded into computers and the AI revolution will have already started. Crushing on Venus. Why does no one like Venus? I'm working on a video about Venus. There's some crazy new technologies. This thing that looks like a manta ray to fly in the cloud tops of Venus, or spider silk spacecraft that are like these tiny little satellites that use spider silk to fly around in the cloud tops of Venus or Titan. So stay tuned. Josh Schultz is asking about asteroid mining, some solution for climate problems that we solve with asteroid mining. What did I get Morgan for? Is his birthday today? Oh, no. So asteroid mining, I'll have to wish him a happy birthday. So what do we solve with asteroid mining? I mean, I think just the idea of harnessing our resources and doing our manufacturing in space is the biggest possibility. That really, if we send our power production, say we send space power stations to space, we send our manufacturing to space, we send our mining facilities to space, we build things in space, then all that Earth has to do is be a great place to live. And then if we need anything, we can send them back down from space. But apart from that, we don't have to really ruin this environment at all. And when you think about this enormous universe, right, we can reach in billions of years in all directions, and yet we'll never find a place that's as good as right here for us. So let's do everything in space so that we can make Earth the best. Oh, Gwen asks, what was the most promising mission project that was canceled that you wish wasn't? I did a whole video on this. There was 3 missions that I thought were really cool that had been canceled. But I'm sure most people watching know the mission that I wish had not been canceled, and that was the terrestrial planet finder. And that was a spaced 3 to 5 spacecraft telescopes flying in formation, acting like an interferometer, that would be able to directly image the planets around other stars, planets the size of the Earth around other stars. That would be amazing. Let's see. Yeah, nuclear reactor in space, right? Build a nuclear reactor in space. Build a fusion plant in space. Medhani Habteramian. Let me do this right. Medhani Habtemarium is there life on other planets? Why don't we try to plant trees on another planet? So we know what kind of environment is on Mars. We know very precisely how awful it is, how low the atmospheric pressure is, that it's made with carbon dioxide, what kind of radiation environment is, what the gravity is like. So we know how bad it is. And we know that, and we have even simulated to see if Earth life can survive there. And trees definitely can't. I can barely keep a tree alive in my front yard. So, but lichen can survive and thrive on Mars, and there are kinds of extreme bacteria that can survive and thrive on Mars. So there is a possibility that we could send this stuff to Mars and it could survive right now. In fact, this is another video we're working on. Is there was a really cool experiment on the International Space Station, this German experiment where they had these little boxes, and inside they had little life forms where they were keeping in various extreme environments, and they were finding that that various kinds of life could survive. So we definitely have life today that's ready to go to live on Mars, but not trees. But maybe you get there, right? You start with lichen, and then when the lichen has been going for a while, then you move to trees. So, Tommy Oliver says, will spacesuits for extravehicular activities ever get any better? Hope so. The spacesuits are rough right now. They're big, very bulky, very hard to move around in, very hard to get into, get out of. But because you have to wear a spaceship, right? When you leave, you're in a little tiny spaceship outside of your bigger spaceship. There are some ideas where, for example, you can imagine, like one of the other ideas is this idea of negative pressure. So to keep your juices in, you can surround yourself in a spacesuit, or you can use like an elastic that provides the same level of pressure that air pressure provides on your body. And there are some really interesting spacesuits that are being developed that can do this. But the problem with them is in your joints. So it's really hard to make a joint, say under your armpit, have the same kind of pressure on the top part of your armpit and the bottom part of your armpit. And so and then things like your hands and neck and things like that. So there's some really fascinating ideas for spacesuits, and MIT, I forget the name of the woman who's doing them. I hope somebody can post this. There's a woman from MIT who has developed some really cool spacesuits that look very, very different. And I think that we will see some of these experimented into the future. And Nancy's mentioning that today's spacesuits are way better than the Apollo and earlier programs, and that's absolutely true. I mean, the spacesuits now are safer and easier to use, and the gloves are much better than what they had to deal with back in the Apollo era. So over time, we just learn more and more and more about what it takes to survive in space. But Josh M is asking, will Mars spacesuits be bulky so they can protect from radiation? Don't think so. There's pretty much no amount of protection that you could wear on a spacesuit that would protect you from the kind of radiation that is happening on Mars. It's just too much. So you just have to limit the amount of time that you spend outside of the protection of your space station or of your colony, right? You're going to be in your lava tube. You're going to be under a couple of meters of rock or ice, and that will protect you from the radiation on Mars. And you know that every time you step out onto the surface of Mars, you are increasing your future risk of cancer. So just keep that in mind. Brad McGashett asks, what's my opinion on nuclear energy? Upsides, downsides? I don't know. I like nuclear energy. It's fine. I think that it's getting to a point now where renewables, with wind power and solar power, geothermal, are just getting so cheap that you don't really need to go with nuclear for just base load power generation. I think there's a lot of other ideas, and I would prefer that you used nuclear for the kinds of things that you can't go with anything else. where you need it to be in a compact situation. But at the same time, if we have to choose between nuclear and coal, I'll take nuclear every day. Like, we've got to stop using coal immediately. And let's, if we have to go with nuclear, let's go with that. But I think renewables is the one that's the most exciting. Like, the amount of energy, the costs are coming down so fast that it's making it hilarious and stupid to use any other form of power generation at this point. And that's exciting, right? Let's get it to the point that you have to hate money to build a coal plant. That's the only reason that you build a coal plant, is because you just hate money and you want to watch your money go away. We definitely shouldn't be subsidizing them. And the rest of the petrochemical industry, it's crazy, right? That we're just going to have to clean it all up again. So stop it. D-Ed, will I be able to travel to space within my lifetime? Yeah, you'll be able to travel to the altitude of space very soon if you want to. There's what's happening with Virgin Galactic with Spaceship Two, and there's what's happening with Blue Origin. Both of those will be glad to take you to help you get your astronaut wings for $100,000 to $250,000 or so. So, if you want to do that, save your money now. Instead of getting a house, buy a trip to space. But the price will come down, once they've been doing it for 10 years, 20 years. I don't know how young you are, but I think you'll have a chance to fly to space if that's what you really want to do and you save up your money. Todd Beeman, would you ever consider doing a small Q&A tour in the U.S.? Would love to attend. I do QAs when we do some of our various events. Like when we do the Astro Tours, or when we did like the live Astronomy Cast 500th episode, a bunch of other stuff like that. I don't think I have the draw to be able to have a lot of people want to show up, so I don't think it'd be worth people's time. So I think this is the way to do it, is for me to be on a computer remotely. Gwym, does your wife like all the space and science stuff as much or close to as much as you? My wife, she wasn't as into it as I was, obviously, but she's like definitely a science fiction nerd and has been into science. Her background is in medicine, and mostly she's more on the nature side. So she loves bugs. So she's kind of opened up my mind on that one. And so we now, when we go on a vacation, I'll bring my binoculars and we'll look at the night sky at night. And then during the day, we will go into the forest and look for bugs. It's pretty weird. But no, we really enjoy. So she's opened my eyes on that front, and you can find her macro photography. She's pretty amazing. Let's see. And so, Osh Kaufman asks, what percent chance you give the success of a 2024 moon landing? Do you think utilizing commercial rockets will accelerate the progress enough to see this realized? 2 minutes. I'll give you 2 minutes. The United States, and especially its commercial partners and international collaboration, absolutely has the ability to get to the moon, and within 2024 for sure. When you look at the Falcon Heavy rocket, which is now launched a second time, there's a lot of other stuff. I think we're going to see, all of that is possible. But the problem is that there are a lot of established political interests right now that are looking to, who have reasons why, for votes, for various sort of established industries that are going to make it really hard. So the only way that would be possible is if the government is willing to turn back turn aside from all of those entrenched political interests and be able to quickly shift to some kind of commercial approach with NASA and increase the funding. And so you're looking at probably double the funding for NASA, at least an additional, say, $10 billion a year for human space exploration to make that 2024 target. So what percent chance? 5% chance? of it happening. I would say, I've been through now, in 1999, I think the president said they were going to be going to Mars. And then in the year 2004, the president said they were going to go to the moon. And then in the year 2010, the president said they were going to go to asteroids. And then 2016, the president said they were going to go to the moon. No, Mars, then the moon. Anyway, each administration changes the mind. So you've got to have whatever the plan is, it's got to be held through multiple administrations, and it's going to have to lay off a lot of people who are voting. So it's going to be tough. So I give it like a 5% chance of it hitting the 2024 deadline. I would say I give it a 25% chance of it being that is still the goal at the end of the current administration and into the next administration. And I give the Chinese a 50% chance of landing on the moon before the end of the 2020s. So, and I would say I'd give Elon Musk or Jeff Bezos about a 50% chance of being the ones to land on the moon before the end of the 2020s. So, all right, I've reached the end of our hour. Thanks everyone for joining me today. This was a lot of fun. I'll let you know if we have guests. I'd love to know what you think. I know both, right? Everything. So I'll try to sort of oscillate back and forth with some guests and some solo question shows. And I know we have some people who are that this is a bad time for them, and I would love to be able to do some shows at different times. So let me know in the comments your ideas, your suggestions. I read everything. So a big thank you to everyone who watched today, and thanks to the moderators for pulling all those questions and putting them into the open space chat. That was really helpful. You could tell I was really using it. So thank you so much for doing that. All right, the next thing, new show dropping tomorrow, all about space-based construction. Patrons will get it a little early. All right. And then a question show later on this week. All right. We'll see you all later. Bye, everyone.